And welcome back. As we go ahead and continue our programming journey with file, we of course have looked at how to read and write to a file. We've even looked at how to append to a file, allowing us to modify things by sticking it onto the end of a file. But now let's go ahead and test to see if we find the end of a file. What do we go ahead and do in that case? Well, if we want to test a text file, we of course have been using the scanner class, so this of course is something that we can use in this approach. When we're using the class scanner, if your program, for example, tries to read beyond the end of a file with any of the input methods, whether it's next int or next line, next double, etc., then your method is actually going to throw an exception. Typically, this is going to be the no such element exception, though this doesn't necessarily hold as well if you have an invalid input in the meantime, such as like a next int looking for an input that's not an integer. This, of course, can throw a different kind of exception. Now, this throwing of no such element exception can be used to signal the end of input. However, we have a more robust way of testing for the end of input from a text file than relying on this exception. Remember, when we talked about exceptions, we said that a lot of the times when we're using exceptions to, dictate our program flow, there's better ways for us to code and program with our algorithms than relying on the exceptions, because the exceptions, remember, they're not the rule, so you should always use them more sparingly than using them as your main approach. So let's go ahead and instead look at the next token. Each of the input methods have a corresponding method that checks to see if there's any more valid inputs of the appropriate type. These methods simply just report back if there's not a suitable next token for any reason, including the end of a file. For example, hasNext int will return false if there's no more file input of any kind, or if the next token is not a well-informed int value, meaning it's not an integer. If it returns true, well, then that means it is a well-informed int. It means we do have an integer value as our next token. We can then process that. So what we ultimately are going to do is check for the end of a text file with the scanner class using these hasNext methods. And we can do this with hasNext int, we can do this with hasNext line, and so on and so forth. Now, the exception classes, no such element exception, the input mismatch exception, and illegal state exception are all unchecked exceptions, which means that any exceptions of these are not required to be caught. And of course, because of that, these are the ones that you're probably going to see when you start dealing with file I/O here. However, again, we can use better ways of handling this than relying on these exceptions here to handle things. But it's good to know that these do exist here and that we don't necessarily have to catch or declare them in our throws clauses in order for them to be part of our program. Now let's go ahead and actually take a look at how we would use this in a program to go ahead and handle those different kind of inputs. So here I have one program. We have two different things going on. We're going to first test for the end of a string value, then we're going to test for the end of an integer value. And in this one, we are going to have an input stream that's going to read in original.txt. And if I look at original.txt, you can see it's all string. So there's no numbers in here for me to have to worry about. Makes it really easy. And what it's going to do, if you actually look, once it reads that in, it's going to also output to this number.txt, and we'll see what it does here in a second. It simply says, hey, we're going to take a line of input. All right, so we're going to say, as long as there is another line in this program, so .hasNext line, we're going to set this string line equal to whatever that next line is. And then, of course, we have this count here, and that count is joining with that string, which means it's going to affix a number in front of every one of those strings with a space as well. Then, of course, you can see we close those input streams because even though we're going to do more file I/O down here, it's very important that we close these streams because we are not going to be working with these streams further. For example, you can see down here we're starting a new input stream, and that input stream is now equal to a new text file. Notice I didn't have to create a whole new scanner object here for it. I could simply just say, hey, the input stream is now this scanner object because it's now initializing it to a new value. It's simply just reassigning it. It's like taking your variable and giving it another value. So we can do that here. And so input stream is now pointing to this text file. And of course, we're going to have our exceptions handled here. But what this one's doing is it's going to use input stream.hasNext int. And if we go ahead and take a look at data, one of the things you'll notice is that there's a string stuck here in the middle. Now what this program is supposed to do for the second half is simply just add up the numbers. So we got 1, 2, 3, 4, and 5. Well, if I add up 1, 2, 3, 4, and 5, what do we get? Well, 1 plus 2 is 3, plus 3 more is 6, plus 4 more is 10, plus 5 more would be 15. However, if I go ahead and run my program, we get the sum of the numbers is 10. And that's because the hasNext int method in this case is encountering an invalid string or integer value. And because this is not a well-formed integer, it's a string instead, the program says, oh, this is the end of the file. And because it's the end of the file, it doesn't add beyond this point. Now, what if you said, you know what, I want you to add everything in here, and I want you to go to the end of the file, but if you encounter a string, I want you to handle it. Now, that would take a little bit more programming. You'd have to approach this with a different kind of paradigm in mind of how we would handle if we encounter something that's not a string value, or not an integer value, rather. So, again, a little bit more coding that you'd have to do, but just wanted to make sure you can recognize that when we use those hasNext methods, if we encounter something that's not valid in here, then, of course, the program will treat it the same as if I reach the end of a file. So just an important distinction to keep in mind there as we go ahead and start working with some of these file.io pieces and we start looking for things like the end of a file.